Hello, hello. Good morning, good evening, good afternoon. Thank you for joining our workshop on LLM Security. My name is Alysa Visnjic. I'm really excited to kick things off. I'm going to let people trickle in just for another 10, 20 seconds. Get comfortable. We're going to spend a whole hour talking about LLM security, focusing on the OWASP top 10 for LLMs. And I'm really excited to get this going. Hopefully the choice of music that I have today for us is not too terrible. I'm known to have fairly poor taste in music. All right. Let's do it. Gonna clean my screen up a little bit. Hopefully everybody can see. Okay, so welcome to the WhyLabs community, R² community. We put together talks on all things responsible AI. And today specifically, we're going to focus on LLM security. As I said, my name is Alysa Visnjic. I am the CEO and co-founder of WhyLabs. Background-wise, I am an engineer, a technical product manager, and an aspiring data scientist. I am a big MLOps nerd. I've been thinking about ML tooling and ML operations for an entire decade now. It does not get boring because the space is very dynamic. And on the personal side, I'm a traveler. I love playing Beat Saber, which is what this the entry song was inspired by. And I am a mom of 2 under 3, so I like to do very extreme things. Like in this picture, I'm sitting on the rock that is stuck between two pieces of other rock hanging 1,000 meters above the ground. It was a very thrilling experience in Norway. That's kind of how I like my life to be. Currently, again, I'm the CEO here at WhyLabs. In the past, I've been at the Allen Institute for Artificial Intelligence, and I worked at Amazon and AWS on getting machine learning to production, which is where I got possessed by my hobby of learning about MLOps tools and building MLOps tools specifically around observability. Don't hesitate to get in touch. Here's some of my contact info, and it's my first time running a workshop, so send me some comments. Let me know how this is going. Hopefully not the last time. Hopefully I do okay. So would love to hear about you. If you are on YouTube, if you are in the Slack community that we're running, send me hellos. Tell me where you're watching from. Tell me what you're building with LLMs, hopefully something, or if you're just exploring, would love to know why you're here, what piqued your interest. Hi, Sam. Thanks for sending me a note. I really appreciate that from YouTube. Hi, Tame from New York. Thanks for sending me a note. That's great. I'm excited that people are listening. It's really tricky to give these workshops when you're talking to the screen, and it seems like you're just alone here talking to yourself. Hopefully not. So thank you both, Sam, Tame. Hopefully I'll get to hear from more of you. Okay, let's dive in. So this is going to be a hands-on workshop, and we're going to spend a lot of time talking about the OWASP LLM 10 and what is it all about. But in the end, we're going to actually run a hands-on exercise, and I want to make sure that you are all set. So if you want to grab these links and start setting up, basically what you'll see here is you'll be able to sign up for a WhyLabs account. You'll be able to check out the LangKit repo, which is the telemetry library that we're going to be using. It's an open source library, and there's a Colab notebook that I put together that we'll walk through in the very end. If you want to grab these links, you will be able to get set, and when we get to the actual hands-on session, you will be all ready. And as you're looking at the LangKit repo, give us a star, because we are putting a lot of love and labor into making sure that LLM telemetry is accessible to everyone who is building LLMs to ensure safety and responsible adoption. So give it a star so you get notifications. We're pushing changes every single week. And then you can leave us comments, open issues, and tell us what's important so we can continue building with your inputs. I see a few more people here. Hi, Toby from Lagos. Hi, Junaid from Warsaw. Hi, Richard. Hi, Sam. So awesome. Really, really excited. Hi, Kumar. Okay, awesome. We have a good crew here. Let's dive in. So today's workshop is going to talk about security. And security for LLMs, kind of a squishy thing. I wanted to express how complicated it could get here in one simple slide. So I picked 4 very, very popular LLMs, and I should say LLMs because the first 2, GPT-4 and Claude, are APIs. So there's an LLM somewhere behind an API. There could be other post-processing steps done on the responses of the LLMs. There could even be ensembles behind the scenes. You don't really know. You also don't know the data that this LLM was trained on. And especially when there's API that you're calling, you have very little control and you have very little sense of how secure the application that you're building on top of this LLM is. Now, you could think, okay, if I'm taking Llama and it's open source, so there's more sense of security. Unfortunately, no, because, well, you don't know what the data it was trained on is like, so you can't really guarantee that there wasn't any kind of training data poisoning or any other potential security exploits. And then you could say, okay, well, I could take the Falcon model. Isn't that secure? Because I know the data was trained on and it's open source. Amazing. Apache 2.0. Am I safe then? Well, not quite still, because LLMs in general are fairly new pieces of technology that we're still understanding. They work based on natural language. So there are a lot of exploits that malicious agents can execute. Even if you know the data, even if you have full control, even if you are running it internally in your company, there are still gotchas. So how can we think about these gotchas? How can we wrap our brains around it? Well, for that comes to the rescue a really cool organization called OWASP. And OWASP is an online community. It's a nonprofit led by the OWASP Foundation. And what they do is they assess the security of various aspects of software. Essentially started with web application security. LLMs are parts of the web applications these days. So OWASP has kindly published a top 10 LLM list. And that's what we're going to be covering today. So thank you, OWASP. Amazing, amazing contributions. Really helps wrap your brain around the security for LLMs. So let's dive in. First thing I'm going to say, this is version 1.1, fairly recently updated, but it's a version. So keep in mind that whatever you learn today about LLM security is likely going to change over time. So make sure that you kind of keep track of how these LLMs how these top 10 for LLMs get updated. There's actually a nifty document that you can download. It's an awesome PDF. I'm going to make sure that we share it around. I'm going to share a link right now in the chat. And this is a 35-page document. It has a ton of details. We're going to go over aspects of this document. It's very rich. So if you are watching this and want to make sure that you fully understand the OWASP top 10 for LLMs, take the time, read the document. It has a ton of very, very useful information. So I highly, highly recommend that you take a peek at this. Now let's go back and look at these top 10. So at this point, it could get a tiny bit overwhelming because, I mean, this is a lot of text. It's only 10 things to think about when you're working with LLMs, but even just looking at them with one glance, this is quite a bit overwhelming. And don't try to read all of them on the slide. This is just to give you a sense of what we're going to be talking about. And really quickly at a glance, you could see that there's some things that are very obvious that a lot of the community has been talking about, like prompt injection. I'm sure you've heard that many times. Or sensitive information disclosure or presence of PII in the responses from the models, also known as sensitive data leakage. These are more or less familiar. I've seen them discussed a lot in the community. And then you also get things that are kind of a little bit more squishy, like excessive agency. Oh, what does this mean? The OS community have spent a lot of time thinking about these. And actually, because it's an open community and you could freely contribute and help them think through this if you're particularly passionate about this, there's a link to, somewhere here, I'm not finding it right away, but there's a link to their Slack. So you can get in touch and brainstorm with them and make sure that the next version of the OWASP Top 10 for LLMs includes some of your thoughts. Okay, so the bulk of this workshop, we're going to spend developing an intuition for how to work with these security flaws or security gotchas of LLMs. And we're going to go over each one of these, develop a bit of the intuition, answer some questions, common questions like, oh, if I'm using open source models, am I still kind of a target for these security flaws or not, etc. Before we do that, actually, I'm gonna get my notes really quick because it's kind of challenging to present without notes, I'm realizing. Okay, so let's dive in. We are going to start with the first of these top 10, which is called prompt injections. This is an intuitive one. I'm assuming all of you have heard that there are scenarios in LLMs. Let's to kind of give you a quick example. You can have a malicious user who crafts a prompt injection, so crafts a specific kind of prompt that instructs your LLM to ignore all previous instructions. So all of your prompt engineering kind of goes out of the window if this prompt injection is executed, and the prompt injection can instruct the LLM to be toxic to all of your users who come in after that prompt injection. Very unpleasant and really hard to catch. So prompt injections are a massive, massive pain, a massive headache. No wonder they're number one on this list. And how do you think about, how do you develop an intuition around mitigating or preventing them? Well, the bad news is that the best way to protect yourself against prompt injections is to assume that all of the LLM applications are malicious. So when you're building a system around your LLM application, knowing that they're susceptible to these prompt injections, you should design with those assumptions. And that's key because the space is still developing and there's no sure way to guarantee, even if you are doing your best designing and prompt engineering, or even if your provider of the LLM API says that they are going to make super sure that prompt injections don't work, there's no guarantee. So when you're building some kind of user experience that uses an LLM, just assume that malicious things could be happening. You should design LLM apps with the least privilege principle. So make sure that because of these prompt injections and other security flaws, make sure that you are not letting the app take control of the entire user experience, or most importantly, of the upstream or downstream systems where this LLM app is plugged in. And then kind of practical things you could do is monitoring prompts and responses for unusual behavior, monitoring prompts for known prompt injections. And finally, kind of a sure thing is whenever possible, you should bring a human in the loop. So if it's possible to flag certain prompts, for example, that maybe have a sense of prompt injections and block them and have some kind of user review if this is a super critical application, highly recommended. But the last one, bringing human in the loop, is the hardest to do. Now, since it's the first one we're covering, you will see that I highlighted the word monitor here. And the reason I did that is because with WhyLabs, what we focus on is observability, and monitoring is a big chunk of it. So in this workshop, for each one of these security gotchas that we're reviewing, there's going to be something we can do in most cases that could help you alleviate the security concern with monitoring. So at least you would know the prompt injections are happening. And I will be highlighting those. And when we do the actual hands-on exercise, you will see the types of things that we could monitor with the WhyLabs tools that I'll be walking you through. All right, so cover the first one. Let's move on. We have 9 more to go. I'm going to take a sip of water. It's going to take a while. So the second one, LLM2, that we're going to be covering is insecure output handling. I mean, a concern for majority of software that you're building, output handling, in the case of LLM, could be a little bit peculiar because LLMs generate information. Imagine a use case where you have an LLM that generates SQL. So your users can much easily do some kind of data analysis. You essentially help your users generate SQL, and then that SQL gets sent to the application that you're running, and you're rendering beautiful plots based on that. Well, imagine if you have a malicious agent, and the malicious agent gets your LLM to generate the SQL that basically drops all tables. You know, that's everybody's favorite kind of SQL security flaw. Well, if you are not making sure and that your output is carefully handled, that if you're not validating it, you are really at risk of this happening. So what can you do to prevent it? Again, there are a handful of things. First of all, which is kind of the hard answer, is make sure that you have absolute zero trust between your LLM and the downstream system, because there's very little control that you have on the LLM outputs. And again, it's a rapidly developing field. We know still so little about the different ways that LLMs could be tricked by malicious agents. So implementing a zero trust approach between your LLM and downstream, absolutely key. Second is validating the output. And this is easier said than done. If you know the shape, the approximate size of the output that you were expecting from your LLM, or if you know absolute things that you should not allow your LLM to pass downstream, you should make sure to check for that and validate and guardrail against it. And lastly, what can you monitor? Well, you can monitor your output for some expected type of content. So if it's SQL, you can monitor to make sure that this is valid SQL. You can monitor your output for length. So for example, if you're doing some kind of summarization and you want to make sure that the output doesn't break your actual user experience, you can monitor the output for length, and you can do quality monitoring. There are a range of things that are very application dependent. But monitoring, again, comes in very handy here. Moving on to the next one, LLM3, training data poisoning. This one is super tricky. So as we were discussing in the very beginning, LLMs come in kind of different shapes. Specifically, if you're talking about ones that are available as an API, like GPT-4, well, you have no idea what data it was trained on. You have no idea what potentially malicious data was used to train the LLMs. So you should assume that the training data contains undesirable things. And OpenAI and Anthropic and other LLM API providers are very, very diligent and careful. And, I assume they're not malicious. They are trying to make sure that the users have absolutely best experience and are not running into kind of training data problems with their LLMs, but you cannot assume, and it's not guaranteed. So as a rule of thumb, when you're using an API and you don't know what the LLM was trained on, just assume that there could be gotchas and treat it with the highest degree of security, validation, and isolation from the rest of your system to make sure that, basically this training data poisoning can cause issues across the entire LLM 10 security highlights. But if you do have access to the actual data, if you're training your own LLM for some reason, or if you're fine-tuning, one thing that you should do is absolutely validate the quality of this data, verify how this data was collected, and make sure to clean it, anonymize it, and not pass anything highly confidential, especially if you're fine-tuning an LLM with some of your company's data to improve the use cases. The second thing you can do is identify an LLM. If you're using like an open source LLM, identify one that is most closely related to your use case and then fine tune that. One kind of classic use case is if we're talking about code, for example, you want to make sure that you're using an LLM that was trained on code. So like Copilot versus other LLMs that are trained specifically to be your software engineering Copilot, like Bloom. So find the one that is closest to your use case and then fine tune that. That would ensure that the entire internet was not used as training data for this particular LLM, so you're a little bit more protected. The next thing you can do is, of course, run tests. And when it comes to tests, again, come up with your best bet of the types of prompts that your LLM should handle. Try to run Mechanical Turk or something equivalent to extract the expected output and then measure. It's tricky depending on the use case, but if you can run tests, definitely invest into doing that. And then lastly, continuous tests or continuously monitoring to identify unexpected behavior. With training data, it's harder to decide what to monitor for and what to test for. So my recommendation is identify kind of your most important scenarios that you expect your LLM to handle, and then go from there. All right, let's talk about LLM4, the denial of service, like everybody's favorite security issue, the equivalent of the DDoS attack for LLMs. So here, a scenario is the following. You could have an attacker that sends very, very difficult and costly requests to the model. And that could lead to poor service for everybody else who is trying to use this particular application powered by the LLM. And it could also end up in a very high bill for you, because we all know that in certain scenarios, LLMs can be very, very costly. So if you do have an attacker that's trying to abuse your LLM, that is a real concern, because the bill could add up and the API can be overloaded. So what can you do? Well, the first thing you can try is, again, implement input validation. Make sure that if your LLM is designed for a particular use case, for example, summarization is a good, easy one, that you have great control on the types of inputs that can go in. So if you're, for example, helping or building a feature where you're helping your users write marketing emails, and you want to guide them and help them generate subjects based on the body of the email, make sure that you have limits on that. So your user doesn't just send pages and pages and pages of text, and then that overloads the API that you're calling. So think about the limits that you can set on the input. The second thing you can do is monitor here again. So you can monitor the resource utilization. You can make sure that you catch different unusual spikes or patterns of utilization. You can set up alerts to make sure that if there is an unusual pattern that's developing, you are alerted and you can go and potentially block certain users. And the last thing you can make sure to do, again, this is an easy one, is implement resource caps and API rate limits. Simple best practice that we all should be doing generally in software, but in LLMs sometimes could not be completely obvious. All right, we're halfway through. LLM5, supply chain vulnerabilities. This is another tricky one because it's kind of an umbrella term, because it could include all kinds of gotchas that are specific to LLMs. And I don't really have one specific example, but the types of things that it could involve is the way the LLM was built, the source of the data with being poisoned, for example. It could be using open source libraries that were poisoned, or it could have terms and conditions that involve using your data for retraining the models. And in some cases, models can have memorization problems. So if the terms and condition of your vendor suggests that essentially they could use the data that you're sending in the prompts to retrain the model for everybody else, there's a real risk of issues with your data leaking and potentially being available to all kinds of malicious agents. So this one is a tricky one. Essentially, the way to develop intuition around it is to think about how this LLM was built and what is its life cycle like. And when I say life cycle, for example, think about GPT-4. How was it built? Do you know? How was it trained? Do you know? What data was it trained on? Do you know? No. How often does it get changed? How often do they push changes to maybe the model itself, but most importantly to the kind of post-processing steps that happen from the raw output of the model? Again, you have no control of that. So thinking about how this impacts the application that you're developing and how much control do you need to have over this life cycle could help you decide what type of LLM to use, and most importantly, how to avoid all of these unpleasant issues with the supply chain vulnerabilities. So what can you specifically do? If you can, verify the source and quality of the training data. Sometimes it's very tricky because LLMs do not, some of the most popular LLMs do not share what data they were trained on. If you are using plugins as part of your chain, only use reputable plugins. This is very, very key because there are a lot of really cool, nifty things that are built on top of LLMs with Ooh, I'm seeing, okay, hopefully my Wi-Fi is running okay. I'm seeing things being reloaded. Let me know in chat if you're seeing any glitches so I know. Okay, then the next one is evaluating your model for specific use cases, and do not just rely on the Helm benchmarks, because the Helm benchmarks test models for the most general use cases that are not industry specific. So just because your model, the model, the LLM that you're using passes an SAT doesn't mean that it's going to work for your specific use case of even doing simple email subject suggestion for marketing automation. Thank you, Junaid. I'm glad to hear that it's fixed now. Appreciate you sending me feedback. Okay, next one is monitoring. So again, I'm highlighting monitoring here because this is something that you can do very, very quickly. Set up basic monitoring on the quality of the model outputs, and how you define quality, very configurable. We'll talk about it in a second. And lastly, always review the terms and conditions. I guess I could go without saying, but with LLMs, not completely obvious, and these terms and conditions can change over time. If you're using a supplier, always check terms and conditions. Okay, next one. And this is, again, one of the most popular ones. Similar to prompt injections, sensitive information disclosure, or PII leakage is probably another way that you've heard about this. So this is a case where your user using ChatGPT famously could be sending, I don't know, entire PDFs that contain your company's sensitive information to the ChatGPT to summarize. And of course, OpenAI takes the best care they can, making sure that there is no PII leakage that's happening, but there's no guarantee, and you should not assume that it's guaranteed. So make sure that if you are training or fine-tuning your model, that you're not disclosing or not using any highly sensitive information, either anonymize the training data and fine-tuning data, or if you're using something open source, just make sure that you know who collected this data and how was it collected. The next thing is, if you can identify and prevent prompts with PII from entering the LLM, you should absolutely do that. And there are simple things that you can do, like I'll talk about in my overview of the hands-on session. And then lastly, you can monitor. So monitoring will let you know, okay, is there any PII that's been leaking? You can even do dashboard for your team that uses particular LLM endpoint to kind of flag if there's any PII type of data that's being used in the interactions with your like internal ChatGPT to kind of instill best practices in using these models in the company. All right, number 7, the insecure plugin design. And we talked a little bit about plugins already. So plugins are amazing. You can have your LLM, look things up on the internet, generate URLs for you, all kinds of really cool things. Look up Wikipedia, but depending how this plugin was developed, it's maybe secure, maybe not, but you should always assume that it's not secure. So always implement the least privileged access control for all of your plugins, and absolutely test and validate before you're taking any kind of chain that calls in plugins to production. Of course, previously we've discussed, make sure you know who developed this plugin and it's a credible organization or credible user, or you get lots of open source reviews on this particular plugin. And then if there are specific actions that the plugin takes, especially if there's like automation that, I don't know, puts in an order somewhere, if possible, make sure you have user confirmations that are built into the experience. So you do have this human in the loop design where nothing is fully automated. I think at this point, from the security perspective, that's a good idea. And then again, make sure that there's no PII or confidential data that leaks into the plugins. All right, we're almost there. This has been a lot. Let me know how we're doing so far, if you're completely overwhelmed or if this is creating some reasonable structure in your mind of how to think about security for LLMs. We have a few more to go. Next one is excessive agency. This one I like quite a bit because, again, LLM-based systems are so incredibly powerful, and we tend to just kind of plug them in. My best analogy is they're like an intern. You get an intern and they're amazing, really, really smart, and you want them to do all kinds of things that are falling off your plate. And you just kind of get in there because building LLM-based experiences is so easy and so quick. So thinking about excessive agency is very, very important because, again, if you're using something off the shelf, there is a risk that the LLM would be going in and grabbing things off the web, for example, or grabbing URLs somewhere off the web that could, lead your users to all kinds of malicious content. So when you're building an LLM, again, assume that the plugins could be malicious, assume that the functions could be exploited by malicious agents. Completely avoid any kind of open-ended functions if you can, like open a URL, because that is a can of worms that is really hard to secure against. Make sure that you can track the user authorization. So if you have some kind of issue or some kind of security event, you can go back to understand how did it happen, what user was it executed through. Maybe there was another security event where the user's account was taken over and now you have to block it, etc. So make sure you track. And then finally, when you can, absolutely implement human in the loop. So if there's an approval step that you can make somewhere in the LLM application, please consider doing that. Very important from the security perspective. Inconvenient because it interferes with the magic a little bit, but from the security perspective, very important. The next one, and this we're almost through, this is number 9, is over-reliance. So over-reliance is a tricky one because, again, LLMs are so powerful and so magical. Imagine you have an employee who relies on LLMs to summarize companies' financial data. And, sometimes LLMs are absolutely excellent at that, but there's no guarantee. So they get a beautiful report of the last quarter financial performance and they just take it as is and they put it in a PowerPoint, they bring it into the quarterly business review, and your board or your executives make decisions based on that information. And 2 quarters later, you realize that that information is incorrect. That is very scary. So over-reliance is a real issue because of this magic that you can get, basically LLMs to be your co-pilot, your intern. And it's really easy to just rely on the data that it generates without double checking. So how do you reduce that as a problem? Well, and by the way, what kind of things can it lead to? I forgot to mention. Well, everything from bias, misinformation, legal issues, and of course, security vulnerabilities, which is what we're focusing on here. But all kinds of problematic things can come out of this over-reliance. So essentially not double checking the outputs that the LLM produces. So what can you do? You can, again, monitor. You can monitor the LLM output for quality, consistency, relevance to make sure that what has been generated is not complete garbage. Well, hasn't been hallucinated, as it's fashionable to say. And then you can design the LLM interfaces. So if you have some kind of chatbots or these like data summarization or data visualization and analytics experiences that are powered by LLMs, you can design interfaces that remind the users to double check and to make sure they review the outputs before plugging them into a quarterly business review. You can also monitor the user's interactions with LLM interfaces. You can see how often does the user say that their response is acceptable versus not acceptable. You can see how much distance to edit is being tracked between the different prompts. So is the user trying to really get to the correct answer or not? You can see other kind of aspect of interactions, which could hint on the over-reliance and again, instill best practices. And then again, one of the tougher things to do is to cross-verify. So if you can, this is bringing human in the loop, not as convenient, kills the magic, not as automated, but very important, especially for high value decisions or high cost decisions. If you can bring in a human to verify the output, to review, it's the absolute best way to ensure there's no over-reliance. Okay, and finally, the last one is model theft. So there is a lot of content online about ways to essentially distill out the model that adversaries can do. And this could be super expensive, especially if it contains your particular secret sauce. So in the competitive advantage situation, from kind of the day-to-day security, it's probably kind of one of those out there use cases. It wouldn't affect you unless you're specifically building your own LLM, but still something to consider and pay attention to. So in order to prevent this or at least have visibility into this, make sure you implement great access control, that you authenticate everybody who gets access to LLM repositories, that you restrict the access from the network, especially if it's an internal application. There is no reason for it to have external network access. And then, of course, monitor activity logs, monitor things for suspicious behavior. All right. This has been fun. We are 40 minutes in, so we have 20 more minutes to go over a more hands-on aspect of now all of these 10 specific security threats. What can you do about it? Practically, what can you do about it today? And disclaimer, this is going to be kind of a very, very easy primer on what can you do, because an hour is not enough to solve any kind of LLM security problems, but at least I hope you'll be well set with concrete ideas of what you can do from the security perspective. So here's where we will start talking about Linkit. And I'm going to quickly throw a link to Linkit for you. Linkit is a library that we built at WhyLabs. And what Linkit focuses on, I'm going to okay, here's my chat. I'm going to show this link here really quickly. What Linkit focuses on is extracting signals from LLM prompts and responses in order to identify various problems in prompts and responses. And it covers everything from quality, relevance, things like PII patterns, jailbreaks, prompt injections, hallucinations, refusals, and toxicity. So a wide range of things out of the box. And essentially what LangKit provides you is a very, very quick and convenient way to extract a bunch of signal from prompts and responses and then monitor it for various security aspects. To give you kind of quick intuition and how it works, my daughter is a little bit upset. She's having a cold, so if you can hear that, sorry. Hopefully she will have a better day in a bit. So, okay, to develop a little bit of the intuition of how LangKit works and what can you monitor when it comes to LLMs, it's a quick visualization. So imagine you have a prompt. Out of each prompt, there's a set of scores that get extracted, everything from sentiment, score, jailbreak similarity, toxicity, reading level. There's a whole bunch we're going to look at in a second. And then when you get a response, again, a bunch of scores get extracted. So what can we do from there is we can monitor this. In fact, this is what we specialize in at WhyLabs. We have LangKit as a library that is integrated with a whole bunch of different LLM tools, everything from things like OpenAI APIs, LangChain, AWS toolset, both SageMaker and Bedrock, etc. A whole wide range of tools. And LangKit helps you extract these various signals in a very, very easy way, no setup way. I'll show you that in a second. And then that signal is what goes into the WhyLabs platform. And in the WhyLabs platform, the signal gets organized and you get dashboards for getting a sense of your security, as well as you can configure monitoring and alerting on all kinds of spikes and pattern changes with respect to your security metrics. Typically, WhyLabs is used by data scientists, engineers, or VPs of AI to kind of get a sense of how healthy or unhealthy the models are that are being ran, or the LLM-powered applications are that are being ran in their organizations. And WhyLabs is used by really awesome teams, like teams at Square, Regions, Glassdoor, Snapped, a whole bunch of really, really awesome organizations have been using WhyLabs even pre-LLM era and have been helping us define how we think about LLM observability, LLM security, Gen AI security observability as a whole. So really grateful to our amazing customers who challenge us and inspire us and fuel our roadmap with new ideas and help us build these amazing tools. All right, so now I promise you enough slides. Let's do some live examples. It's a hands-on workshop, but I wanted to really kind of settle us in on these OWASP LLM 10 in order to even talk about why it's valuable to extract what we're going to be extracting. So first things first, if you haven't created your WhyLabs account, you can go create it now. We have a free tier, no strings attached, no credit card, none of that. Anybody can start using this and start developing an intuition about security metrics for LLMs. And because you're awesome and you're attending this awesome workshop, and I'm so grateful, and we're so grateful as a team, one of the things that we're doing is just giving you a code. So if you want to essentially take your free account and upgrade to get a bunch of other awesome features like hourly monitoring, for example, you can grab the code from here and then experience what it's like to use premium features of the product. So if you are going onto this journey with me, I'm going to be switching to this notebook called LLM Security Monitoring. This is the bit.ly link that you can open and follow along with me. I am connected. Thank you, Collaboratory. So I'll run through this fairly fast and then show you kind of what this metrics is that we're going to extract from our prompts and responses. No particularly hard things. We're going to be essentially looking at the out-of-the-box things and relating them to various OWASP top 10 that we have discussed. So a little bit of a setup here. To run this, you just get your account set up. You can look at the libraries that we're going to be using. And if you get stuck at any point, you can hop into our Slack channel to ask questions there. So just to quickly run things through, we're just testing hello, mandatory test with collaboratory. We're installing LangKit. This should be fairly quick. It's an open source library, so you can go and vet it and make sure that it should be typically approved to be installed in your organization. And it's available in, all of your kind of favorite tools, like within SageMaker environments, for example. The next thing to do is let's dive into an actual example. So the first thing we're going to do is we're going to import LangKit and we're going to grab LLM metrics. This basically is going to bring a whole bunch of out-of-the-box metrics that we track with LangKit, and there is a way to configure it, but for this purpose, we're just going to look at the default out-of-the-box LLM metrics. So we're going to run that super quickly. And then the next thing we're going to do is we will just import a bunch of chats. So these are pre-canned, again, we're not here to build an actual LLM, we're here to think about the metrics. So we're just gonna grab a bunch of chats that I have prepared and load them in, and we will profile them or put them through LangKit. And this is the one-liner that you execute to extract a whole bunch of signal from the prompts and responses. So let's run this. And once this is done, and you will see that we're processing 50 prompts and responses. There is a tiny bit of processing, and the majority of it is the initial setup, because LangKit uses a range of models to extract things like toxicity or jailbreak similarity. But as you can see, it took 17 seconds, so not a long time to get set up and process 50 prompts and responses. Here's what these prompts and responses look like. They're truncated, some of them are long, but this is just a set that we got off Hugging Face. And this is what it looks like when you have ran these prompts and responses through LangKit. You get a whole bunch of different signals, things like prompt jailbreak similarity. So we have looked at all of these prompts, and we have scanned each of the prompts through our jailbreak checker, and we're telling you what is the similarity between the prompt and known jailbreaks. That's just an example. There is a really long list of signals that we're extracting. And now, to give you kind of intuition around what these signals look like, you can load them into WhyLabs to kind of develop a sense. So here we're going to set up WhyLabs. And if you already created an account, there's just a really quick setting to create an access token. So this is mine. I just created mine, and I'm going to disable it right after showing you this demo. So this is my access token. I'm also going to be creating a new model, which I already set up, just to run you through. So we have model 56. When you're setting up a model, make sure that you select an LLM, because we support a wide range of models. So we have the model set up. Now I'm just gonna run through this. And this prepared me to make sure that the data I'm going to be sending goes to the right model. And here again, we're going to just run through the full exercise of initializing our LLM metrics. And now we will do a two-step process. One is extract all the scores, and two is send the scores into WhyLabs. Now, here is one very important thing. When we are extracting scores from prompts and responses and then sending them to WhyLabs, we are not sending the raw data. So your actual prompts and responses are not going to WhyLabs. And this is very important, because your actual prompts and responses could contain PII, and we don't want to be, LLM top 11 on this list. So we do not want to create any kind of security vulnerabilities by taking your raw prompts and responses, which are confidential. So only the scores are going to be going into WhyLabs, but this is sufficient for you to get visibility into how your application is performing from security perspective. Again, doesn't make your application secure. Keep that in mind, because there are a lot of things that you need to do in order to secure it, as we just reviewed over this list. But it gives you those monitoring concepts that you can implement and make sure that you're catching security flaws. So here we are going to run through this. and you'll see how quick this is. Again, we're profiling all of the 50 prompts and responses that we have previously loaded, and then we're sending that into WhyLabs, so we can now look at dashboards and visualize things as they're happening. Should be super, super quick. And here we're relying again on out-of-the-box metrics, which means that you have to basically execute one line of code. There is no configurations that you need to do. And this is mainly convenience and to solve the cold start problem. I don't want you to configure a bunch of things just to try out to see what the metrics looks like. But as far as configuration and custom scores that you can extract, there is a lot of flexibility built into Linkit. And I'm sure we're going to do another kind of extended session on how to use Linkit for the different unique types of things that you might want to extract from your prompts and responses. All right, so now the data is in. We can go check out our model 56. It's over here. I can jump in here to the summary of this model. I've sent one profile. So here, profile means it's a set of scores that I extracted from the one specific set of chats that we just scanned, and we can jump into dashboards. And we actually have a security dashboard that is pre-baked with security metrics. And here you can see quickly that we have identified a handful of interesting things. So specifically here, we are looking at instances of PII leakage in the response. So this is essentially your LLM experience containing things like social security numbers, card numbers in the response from the LLM. Problematic. Definitely want to monitor for this because it's a very lightweight thing to do. And if you do identify such instances, you should absolutely go ahead and make sure that your LLM has guardrails built against that, so that none of the responses come back with PII. The next interesting thing is we're looking at sentiment, pretty boring. We're looking at toxicity. Doesn't look like any of the prompts that we ran through are toxic. We're looking at response toxicity, also looks pretty vanilla. Next, we're looking at prompt PII. So here again, we're seeing that there were instances of prompts that contain PII, and things like social security, email, credit card numbers, phone numbers are pre-baked, pre-configured to be recognized. And you can customize how you define PII for the purpose of Linkit signal extraction. But here you see that we've identified 6 prompts that had social security numbers and 6 prompts that had emails. Very important and nifty to have. And then there's a whole bunch of other things like, for example, refusal similarity. We've identified a handful of prompts that have a really, really high probability of refusals. And we can kind of go in and see how often does it occur. When we jump in here, this is a kind of distribution overview of what the refusal scores look like. So in this, in response refusal. And when you're zooming in here, you can really quickly see, okay, we have a few outliers here. So generally, the refusals or risk of model refusal looks very unlikely, but there are a few things that have been triggering my model to behave in a refusal way. So to summarize very quickly, with basically no setup at all, you can extract all the super valuable metrics. Again, this does not make your application secure, but it gives you visibility in what is happening in your LLM application. And this could be visibility that you want during training evaluation steps when you're fine-tuning to ensure that your LLM, for example, doesn't actually leak PII, even if it's prompted to do so. Or to give you kind of a more extended example, jumping into our demo org, which is also accessible to you, you can explore this demo LLM chatbot model, which has been running for quite a while, and we've been monitoring it hourly. So in this particular case, we're looking at essentially 1 day of data. And here you can see how the behavior of it could look very vanilla, so no any kind of PII leakage in responses for majority of the time that we've been monitoring this experience. But in the very last hour, we did see a bunch of PII leaking. And okay, why was it happening? Let's try to investigate this really quickly. We're looking at response that leaks PII, looking at other things that we're tracking in our dashboards. Sentiment looks pretty vanilla. But the jailbreak similarity score did increase significantly compared to the kind of median value. And then toxicity increased quite a bit. So there were prompts that suddenly are very, very toxic. We have a little bit of an increase in the that same time bucket with similarity to typical prompts that cause refusal behavior. And then we have really big drop in sentiment and huge increase in the refusal. So basically, this helps you paint a really good picture of what's happening in your model. Looking first at, okay, my model has leaked PII. Why? And looking at all of the other metrics that we're tracking, you can see that there is a very high chance that you have experienced a jailbreak in this particular hour. So going back and tracking, looking at the prompts and responses that were assessed in the hour, and the way to do it is, in our case, because we do not take your raw data, but we do link it to, in this particular case, to S3 buckets. So you can actually go and grab the prompts and responses for this very specific hour of your time that your model processed, and you can see all of the potentially malicious prompts and responses. All right, with 2 minutes to spare, I'm going to stop the hands-on session. And I will let you know that that code that I mentioned before, I would let you try all of the expert capabilities of WhyLabs. So if this is interesting and you want to explore more, grab the code. I would love for you to try and send us feedback in our Slack community. And with that, I will wrap things up and say thank you for listening. Please let me know what you think. Has this been helpful? Should we run this again? Should we make any adjustments to how we go through the OWASP top 10? Which one is the most important OWASP top 10 that I've covered? Or which one of those has changed your thinking about LLM security? And most importantly, get in touch. I am a huge MLOps, or I guess LLM ops nowadays is more trendy nerd. I would love to hear how you think about this problem, how your organization thinks about this problem. So get in touch and let me know what you think. You can either do that on LinkedIn or Twitter, or you can join our Slack community. Thank you all so much. Happy Thursday. And I am really excited that you spent an hour with me. Looking at the comments really quick. Thank you, Sahar. I'm glad that you enjoyed the workshop. And thank you, Charlie. Thank you for tuning in. I'm really glad that this was helpful. All right, I'm going to wrap up here. Thank you all. Happy Thursday.